What if black holes aren't what we think they are? We imagine them as cosmic monsters, collapsing stars so dense, not even light escapes. But deep in the math of space-time, there's a twist. Some physicists believe these dark giants might have an alternate identity, a hidden truth, disguised behind the event horizon. They call them Gravastars, and they could be the universe's biggest impostors. If they exist, they don't just change how we see black holes. They change how we understand reality itself. And here's the kicker. We might have already seen them and never realized it. So, what exactly is a Gravastar? Short for gravitational vacuum star, it's a bizarre theoretical object that looks just like a black hole from the outside, but it's radically different on the inside. Imagine a collapsed star that almost becomes a black hole. Just before forming a singularity, quantum effects or exotic matter step in. And instead of a point of infinite density, a gravastar forms a bubble of vacuum-like energy surrounded by an ultra-dense shell of matter. It's like a hollow cosmic sphere, a marshmallow, with a hardened outer crust and a strange, stretchy center that behaves like dark energy. Gravastars don't have an event horizon. That means light might bounce off their surface instead of being trapped forever. They might even emit faint radiation, clues that could set them apart from their darker cousins. But on the surface, nearly identical. Now here's where things get really strange. Black holes and gravastars could appear nearly identical. Same mass, same gravity, same bending of light. But their cores couldn't be more different. A black hole collapses matter into a singularity, an infinitely dense point. A gravastar, on the other hand, avoids that singularity completely. Inside, it contains a hollow region filled with something like dark energy, a repulsive force that counteracts gravity. And while black holes have a one-way event horizon, the point of no return, gravastars don't. Their outer shell might reflect light or energy. That means, in theory, you could send in a signal, and it might bounce back. That tiny difference could mean everything. In gravitational wave observations, black hole collisions produce a predictable chirp. But some researchers think that if gravastars collide, we might hear a faint echo, a second wave, a whisper from the edge of physics. If we can detect that echo, we might finally tell these two cosmic giants apart. And the implications? They could rewrite astrophysics. So how would a gravastar form in the first place? The idea begins at the death of a massive star. Normally, when such a star runs out of fuel, gravity takes over, collapsing the core into a black hole. But what if something stops that collapse? In the Gravastar model, just before a singularity forms, an exotic pressure arises, perhaps from quantum fluctuations or an unknown form of matter. This pressure creates a bubble of repulsive energy, similar to the mysterious force driving the expansion of our universe. This vacuum bubble halts the collapse. A thin but ultra-dense shell forms around it, locking the structure in place. This isn't science fiction. These ideas come from attempts to merge Einstein's general relativity with quantum mechanics, the holy grail of physics. It's a scenario where gravity almost wins, but the universe fights back. The result? A stable object that behaves like a black hole, but holds an entirely different secret inside. And if gravastars really do form this way, then every black hole we think we've seen might need a second look. Here's where things get even more mind-bending. The energy inside a gravastar isn't just empty space. It might be a form of dark energy, the same mysterious force pushing the universe apart. If gravastars contain this energy, they might be tiny pockets of cosmic expansion, like mini Big Bangs trapped inside a shell. And it goes deeper. Some physicists speculate that gravastars could be related to dark matter halos around galaxies, or even serve as stable structures in a universe filled with strange particles we haven't discovered yet. In a way, gravastars might not just be black hole imposters. They could be the missing link between quantum physics and the large-scale structure of the cosmos. Maybe they're not errors in the fabric of space, but keys to understanding its deepest design. If gravastars are real, how would we find one? That's the tricky part. From a distance, gravastars and black holes look the same. Same mass, same gravitational pull, same bending of starlight. But recent advances in gravitational wave astronomy, like the discoveries made by LIGO, might hold the answer. When two black holes collide, they emit a final chirp as they merge. But if two gravastars collide, there might be echoes in the signal, a faint, delayed ripple caused by waves bouncing off their inner structure. It's subtle. But some scientists think we've already detected those echoes, and just didn't realize it. Another clue might come from light curves. If gravastars have no true event horizon, infalling matter might heat up and emit radiation differently, potentially visible to instruments like the James Webb Space Telescope. And if they're common in the universe, then the next strange object we find might not be a black hole at all, but a gravastar, hiding in plain sight. Let's go one step further. What if black holes don't actually exist? It sounds crazy, but some physicists argue that every black hole candidate we've found could actually be a gravastar or another exotic object we don't fully understand. Singularities, points of infinite density, are places where our math breaks down. They're signs that we're missing something deeper, something elegant. Gravastars offer a possible way out. They avoid infinities. They avoid paradoxes. And they might be more compatible with quantum theory. If this idea proves true, it would mean we've misunderstood the most powerful objects in the universe for over a century. Maybe black holes were never the monsters we imagined. Maybe they were hollow all along, filled with secrets waiting to be uncovered. So what do you think? Are gravastars real? Are black holes just the beginning of something far stranger? The truth is, we're just starting to understand the dark, hidden architecture of our universe. Gravastars might be rare, or they might be everywhere, hiding behind a perfect disguise. If you love diving into these cosmic mysteries, black holes, gravastars, alien physics, make sure you hit subscribe. Join us on this journey through the unknown. Because out there, in the shadows of collapsed stars, something incredible might be waiting.